On average, the subjects who had little protein rejected unfair offers twice as often. But how can this surprising result be explained? In their search for biological evidence for this observation, the scientists carried out blood tests.
We will send the blood to the laboratory for analysis. We will measure the level of hormones and amino acids in the blood. For hormones, we are interested in insulin, cortisol, adrenaline, and adrenocorticotropic hormone. And for amino acids, tryptophan and tyrosine.
Of these substances, the most important is tyrosine. The amino acid is one building block of a protein that is key to brain function, dopamine. This molecule ensures communication between neurons involved in motivation and risk-taking. The results of the blood analysis show that subjects with higher levels of tyrosine in their blood are more willing to accept the unfair offer. In other words, what we eat can within hours subtly alter the chemistry of the brain and thus the communication between the neurons. Enough to guide some of our decisions. Experiments are continuing in Lübeck to confirm this result. The implications are wide-ranging.
Since we eat 3 times a day, every day, we realize that food has immense power, that of modifying and shaping mankind. So it's essential to think about how we can use food to promote our well-being and optimize our mental state.
Not only does an unbalanced diet affect our brain functions and behavior, and our meal plan interfere with daily decisions, it also becomes increasingly clear that diet plays a decisive role in our mood and possibly mental health. But what about junk food, dripping with sugar and bad fats? What would happen if we ate more of that? This is the focus of research here in Australia at the University of Sydney. Margaret Morris runs a laboratory where rats are fed the kind of junk food that you find in supermarkets or cheap fast food restaurants.
Our experiments use a range of Western foods of the type eaten by all of us. So we feed our rats meat pies, chips, cakes and biscuits, the sorts of foods that are readily available and cheap. So we are modelling the Western world.
The first consequence of this diet, the rat doubles its food rations. The animal never seems satiated, but that's not the most surprising outcome.
One of our chief interests is the impact of this diet on the animal's memory. And we can measure this easily in the rat using a task known as the novel object and novel place task.
In this test, the researcher places objects in the rat's cage. The animal comes over immediately to examine them. Rodents are very curious by nature. Once it's completed its examination and memorized its surroundings, it's temporarily removed.
We then place the animal in the arena with one object that's been shifted.
On its return, the rat spends more time examining the object that has changed places because it already knows the other objects. They're engraved in its memory. The rats, stuffed full of bad foods, behave differently.
What we observed is the animals eating a high-fat diet or a high-sugar diet or the combined high-fat, high-sugar foods were less able to recognise, to remember that that object had moved. They explored the two objects about the same. That shows an impairment of their spatial memory.
The overfed rats have not only damaged spatial memory, but also other malfunctions that sound a warning signal for the scientists. They point to damages in the hippocampus, a small region nestled in the center of the brain. It's essential for learning and the consolidation of memory. Recent studies show that in humans, a too energy-rich diet also interferes with the hippocampus.
We see, for example, that the quality of people's diets is related to the size of their hippocampus, to the size of their grey and white matter volume, and there's starting to be intervention studies. So, for example, we see that only 4 days on junk food type diet will have an impact on cognitive functions that are related to the hippocampus.
Margaret Morris is now seeking to understand how sugary and fatty foods disrupt the brain of her rats to the point of affecting their performance. She has a hypothesis, namely, eating too much fat and sugar triggers an inflammatory reaction that spreads to the neurons.
So, in response to these foods, there's a general inflammatory response all around the body. This has been well described in obesity, but it now appears to be quite an acute response as well. And what we find is that inflammatory molecules such as cytokines are increased in response to the diet.
An overly rich diet confuses the immune system. It responds by triggering an inflammatory reaction, especially in fatty tissues. Our fat masses release substances that then propagate this inflammation throughout the body. Neurons were thought to be spared this effect behind the protective blood-brain barrier, the semi-permeable membrane that separates the circulating blood vessels from the brain.
So there's increased inflammation in the whole of the body, and we think that this may spread to the brain. That's because the blood-brain barrier, which normally protects the brain from inflammatory molecules, may be impaired, in fact, by the diet and become leaky, allowing traffic of molecules into the brain.
The inflammation infiltrates the meninges and then triggers a surprising phenomenon. In her laboratory, Sophie Ley has shown in her overfed mice that certain immune cells in the brain, the microglial cells, begin to devour neurons.
These microglial cells within the brain are important because they can eat dead neurons. But when they're deregulated, especially in a situation of unbalanced nutrition, they start to eat neurons that are alive. Therefore, by consuming these neurons in excessive numbers, eventually they will destroy or participate in the destruction of neural networks. That includes neurons that are alive and that should be functional.
This reaction of the microglial cells could be filmed in vitro. The images show how energetically they move. The red objects are fragments of neurons that they ingest. In an obese mouse, the activity becomes frenetic. This phenomenon is suspected of significantly affecting the functioning of the brain.
we've been saying to people for 30 years, don't eat these foods, you might have a heart attack, you might get cancer and diabetes. It hasn't worked to change people's behaviour. We hope that if people understand that what they put in their mouth is actually really essential to the health of their brain and that of their children, that might have a more profound impact on people's dietary choices.
Microscope, micromanipulator, and ultra-sensitive recorder. Xavier Fioramenti is at the helm of an apparatus that can record the electrical activity of a single neuron. The principle is simple. A slice of mouse brain is immersed in a liquid that keeps it alive. The researcher approaches it carefully with an electrode. It's a meticulous operation.
Here I go down the pipette in the slice of brain. And now we will approach this recording pipette near the neuron to make contact. That's it, we made contact. And now we will be able to measure the electrical activity of the neuron. The upward peaks that we see are potential areas for action. This is how neurons encode information.
The time that elapses between the peaks is the message sent by the neuron.
Now we will increase the glucose concentration in the bath, and we will see if this cell responds to this increase in concentration of glucose. As it can be seen here, this cell responds to the increase with more electrical activity. There is more potential for action than what could be seen here before the increase in glucose concentration.
This signal comes from a single cell, but in the brain, the neurons are all connected to each other. That makes the scientists suspect that glucose has the ability to modify the activity of entire brain areas that control emotions and pleasure. Is this how sugar ensures its grip on our will? This is, for the moment, only a hypothesis. But today, sugar addiction is the subject of intense research in laboratories. And what appears more and more clear is that the power of sugar is similar to that of a drug. Serge Ahmed is one of the first to provide proof with a very simple experiment. Step 1, he raised rats, giving them cocaine and sugar. Then, after weeks of this diet, he presented the animals with a choice.
We have the situation in which the animal has the choice between a lever that is connected to a syringe that contains a drug solution, and the drug in question is a hard drug like cocaine and heroin, and on the left, a lever allows him to control a syringe that contains a sweet drink. And there we see the animal chooses to take the sweet drink.
The rats selected the sugar water 4 times more often than the drugs. It can't be called a glucose overdose, but the irrepressible desire is plain to see.